Alright, hey everybody again. This is Jay Helix, and this time continuing with our LT4 Supercharger tuning series. So in this video what I wanted to cover is the VCM Scanner setup that I use. Um, this might not be very new information for folks that's already familiar with the VCM or the HP Tuners software suite, VCM Editor and VCM Scanner. But in any case, it might be helpful for folks that are out there. And just for completeness, I wanted to show how I got mine set up. First thing I'm going to do though is just do a quick recap of the steps I take when I tune. So basically, kind of as we talked about in the first, or not the first, but a couple of videos back, I always start off with getting the as found file, and this is the file that you'll be working off of, so you don't want to edit the original copy. You'll just be making edits to the original but saving it as a different file name, so that way you keep the original around in case you need to reference it. This one kind of depends on the particular application and what you're doing to your vehicle, but in this particular project with the LT4 Supercharger, I needed to make some basic configuration changes. So as we did there, we went and created an initial start tune. So these step 2 and step 3 is going to vary depending on what you're doing, but pretty much step 1, step 4 and on is going to be kind of the same steps that at least I take, regardless of what I'm tuning for. Meaning regardless of what I did to the vehicle, these are the steps I take. So the real meat and potatoes to it is doing the map tuning, doing the speed density tuning, then attacking the timing, going after virtual torque if it's needed. Sometimes you don't need to modify that, and then the last one I do is drivability. So this is really these are kind of the ones to get the vehicle in a relatively good state, where it's drivable and you can go into power enrichment mode, not have to worry about things going wrong. And drivability is really about just fine tuning specific things. So if you're if you didn't really get your math curve and your speed density dialed in, that could be something you can finish off in drivability. Maybe you encounter some knock and some different driving conditions, you can catch that in drivability. So that's kind of my catch-all to really polish off the tuning process. So jumping over to VCM Scanner, there's lots of good YouTube videos out there on how to add channels, how to create charts, how to go into the graphs, how to navigate HP tuners. I'm not going to really cover that in this. The purpose of this is really just jump right into what are the actual PIDs, and the channels that I'm using, and how I'm showing that. So, and really what it ties back to is how is grabbing channels that that I need for the step that I'm in. So what I mean by that is kind of coming in here, let's work up here at the top with this first group. So in any case, RPM is pretty important to have. So out of all of these here in this group, the one that I really pay attention to is really RPM. Speed's another one, kind of a nice to have. Coming down in the group 2, this is getting into group 2 and group 3 here are really getting into the virtual torque area. So one is based off engine torque, and the other one's your axle torque. So this gives you insight into how your virtual torque is tuned, and if it's causing any discrepancies or any holdback from what you think you should be achieving. So getting back to group 2 here, I have this is the delivered axle torque, so what the ECM thinks is delivered. Over here we have the driver demand axle torque, so what the driver's allowed to command. This down here, this blue one, is your coming from a virtual torque, and same thing with the third group here. So this is similar to this, but it's in your an engine torque and not axle. So you have the only difference is we now add another parameter, which is the peak torque. And we'll cover more in depth in the virtual torque video. But pretty important to have all these in place. You know, this really allows me to see that hey, one of my virtual torque tables is, whether it's the torque model or the torque management, is starting to kick in and either pulling out timing or closing the throttle blade. So these are pretty important to have and to watch. Stepping down here to the next group, so the big one out of this guy for me is the knock. You know, that definitely want to avoid situations and where I have knock, so that could be based on timing changes you've done, it could be based on just you know, your fueling and all different kinds of variables. It's just nice to know and log if you have any knock. The other two that are pretty important that I rely on quite a bit in this group is, you know, what my accelerator is actually doing. So this is me actually physically pushing down on the accelerator, and then what is the throttle position sensor allowing to you know, basically these in sync. Now they're not exactly a 1-to-1 ratio, but you know what this can help you with is if you got a 99% acceleration, but your throttle's only open at 40-50%, that's an indication that something else, there's something that's computer doesn't like and is not allowing to allow more air coming in the system, and that could be due to your virtual torque system or something else. So these are pretty good parameters to log to indicate those type of issues. Just overall spark advance, that's good to have too. The MAF frequency in hertz, you know, it's good for your MAF tuning. See the mass airflow in pounds per minute. I don't think I use that one quite a bit, but I would say pretty much all of them in this group is, maybe except for the MAF pounds per minute, are pretty good to capture. Coming down to the next group, so this is the injector pulse width in milliseconds for bank 1, and this one's for bank 2. Then we have the O2 sensor in millivolts, bank 1 and bank 2. So the O2 sensors, those are just good to have to make sure that, I guess, that you're switching. You know, I kind of wish you were able to get the voltage levels of the pulse width, injector pulse width, so you can kind of see the action over here, that the injector is actually in sync with when the O2 goes from a lean to rich and rich to lean condition. But it's, in any case, it's still good to look at. The timing here is more critical than, I would say, your injector duty cycle, and I mean that in the context of with Gen 5s, you know, older generations of VCMs, a lot of the injector duty cycle is kind of what you go off the most. That's not so much the case with Gen 5s with the DPI, the direct port injection. So these are good to have on your logs. And then the last group here is out of this group, you know, pretty much all of these I pay particularly a lot of attention to. Maybe not so much torque management, but you know, it's nice to see what my ECT was. Really, more importantly than ECT is just what my intake air temperature is. But outside of those, the two big ones that are really critical is your wideband. So this is my PLX wideband, and then so this is going to show, you know, what actually is the actual fuel ratio versus what I'm trying to command, and so I can use these to do my MAF tuning. So this is you know, it's not a lot, but this is just how I got mine set up. Now you set yours up however you want. You don't have to make it look just like this. You don't have to have them all grouped just like this, but this is what I'm using. And then, yeah, if anybody, you know, needs any help with what specific parameters I'm using to set these guys up, you know, feel free just to reach out in the comments, and I can help out with that. So I guess the next one would be the graphs. You can see I got quite a few graphs here, but really the most important ones that I use for tuning is my knock. So that is pretty important. so I can modify my ignition tables, my spark tables. This is where I would do my MAF transformation curve changes. And again, these are all videos that are out there on YouTube already. Books, different articles that can walk through how to set these up. This is my older speed density data table I was using, but now that I got the 4 bar on there, so that's a 425 kilopascal LT4 map sensor. So that's 4.25 bars that I can read. So I had to redo my data tables for that. One of the biggest difference being that this only goes up to 0.93 of this ratio that comes out of the VCM editor, whereas the 4 bar goes all the way up to 1.24. So pretty good, pretty important to make sure you have that set up correctly. Let's see. So outside of that, yeah, I think those are the most important ones here. These guys up top. So you can see there's not a whole lot that goes into what I log to get the information I need to allow me to come back and do these the tuning for these different steps. So yeah, I think I'll keep the video pretty short and to that. Again, if anybody wants to see more information about how things are set up specifically that I got, feel free to reach out on the comments, and I'll try to help you out there. But yeah, next we'll actually get into the actual tuning process that I like to do for these. So thank you, and see you in the next video.